Video, I'm going to share with you what I think is a pretty cool program that I've created. And what it does is, I'll refresh it to show you. So starts out, I call it an angle calculator. And this could have many uses, and one of which would be in some game design elements. And the way it works is you have a starting coordinates and you um, select an angle that you'd like, in this instance, is a ball and a line to travel in. And then the program figures out the next coordinates that you would need to get to if you want to maintain that angle. And I actually have built in here, if you use the left and right arrow keys, you can actually change the angle. So this is at 65, and I can go up and down. It moves by multiples of 5 as I move it there. So a great this, you can see how in a game you might have something shooting and you want it to maintain an angle. And this will allow you to do that. So let's take a look at the code. So this is a traditional JavaScript canvas setup. I have the HTML here, and then our script where all the action takes place. This kind of sets up the canvas. Standard code that you need anytime you have a canvas, right? I have a ball object. I have the message that you see at the top of the screen is right here. That's a string variable that starts off saying angle of line. So then I have three sets of coordinates. So this one, what I call px1 and py1, this is the starting position of the ball, and this will reset with new values each time the ball moves. I'll kind of show you how that works. This is the starting point for the circle right here, this little circle here that never moves. And then over here we have px2 and py2, and that is that will take the points that the ball is going to move to. Again, we'll show you. That's going to need to be calculated based on the first position in the angle. This is the angle start position, 90 degrees. And then this is the calculated angle. So the one is the one that we want it to be, and this is what we calculate, which these should be the same. Our goal is to match the one we want it to be. This is the distance the ball moves each time, just 5 pixels. And so the init gets called when the page loads, right? And we just do a setup canvas, which again, there's no really need to dive deep into this, but it's just kind of standard stuff that you would use to set your canvas. Our width and height is the actual browser's width and height. That's the only thing that's a little different than typical canvas setup. Otherwise, though, it's very standard. And I will, of course, share all this code with you. And then the other thing we do right away is set the angle. This calculates the angle to match with the angle that we want it to be. I'm going to go over that method in a second, but first I'm going to show you what's going on in the draw method. In the draw method, this is everything that's going to appear on the screen. First thing is we draw this clear rectangle that basically clears the screen every cycle, and then we display our text. It's a blue color, 20 pixel point, and Arial font. And then the starting coordinates and the message is displayed there. This is the static circle, the one I was talking about. That's this circle here, right? And that is 100 pixels in diameter. And so that just draws that circle. That doesn't move anywhere. And then this is the ball that we draw. and we are tracking it with the ball X and ball Y variables, which I'll show you how they get set. Radius, which I believe is 20. Again, I'll show you that momentarily. But this is where the ball is drawn, and that will continue to move. This is the line that follows close behind the ball. This is the PX1, and the PX1 and the PY1 is what really follows the circle. This starting point is kind of static and doesn't move. You can see that that's the same as the coordinates here. PX1S is static; it stays the same. Okay, this is where it moves to. This is where the line starts, right? And so that's everything that's in the draw method. Then we have these two different methods, one called ball move and one called my function that does all the calculations. The set interval, this is how many times per second the draw method is called, and it's going to be called 10 times per second because you divide that into 1,000 to figure that out. So the ball move, so this is what I was talking about. So the X and Y coordinate is going to be equal to PX1 and PY1, and you'll see that in the my function method how that gets calculated every cycle that it gets called here, right? And so the only really significant thing going on here is that we're setting the ball X and the ball Y, and we have this little if statement. So if the ball goes off the screen, you'll notice that it actually will reset back here, just so we can kind of keep track of, otherwise it would be lost outside of the screen. All right, so let's look. Here's the anything semi-complicated is happening in the my function method. So, and some of the stuff I had to look up and refresh because I forgot how to do that, but you can calculate points. Like I said, we know what we know is 1 point and the angle we want it to be. We also know the distance. Remember, that's 5 pixels, right? And so to calculate the next position, this is the formula. You get the sine of the angle, 90 degrees, right? And you divide pi by 180, and then you also get the cosine, same deal. So you have the sine and the cosine of the angle times math over 180, and then what you do with that is to get the new x position, you times that by the distance. To get the new y position, you do the same thing, times the distance times the cosine. So for the x, the distance times sine. For the y, the distance times the cosine. Okay? And so that's really the key thing that we're doing here. This is kind of just to show you that it's almost like a proof of concept that if you, so now we have these 2 points, right? We have PX1 and we have the starting point and the point we're moving to. And this is just shows you that you can actually calculate the angle based on those points. And it's almost like just proving that we did this right. All right, so if this is the new position, then if I do this, the angle should come out to be whatever I wanted it to be, right? Like, so in this instance, the angle should calculate to 55. And there's actually a second method for doing that, but I'm not actually using this, but I just wanted to show you. This is really the same as this. It's kind of combined into one line. But you're basically getting the 1 point and subtracting it from the other point, right? And then dividing, so the x, subtracting each of the x positions from each other, each of the y, then dividing, then you're going to get the reverse tangent, right? And you're going to times that by 180 over math.pi. So that's basically how you get the angle. See that this one just kind of does it all in one line. And this is if you wanted it in radians instead of degrees. And so I got, like I said, I get the that angle, and there's the only thing, this angle, what's going on right here is the positioning. So I have this as being um, 0, which makes sense, right? But when this calculates, that's not 0, so I do just a little subtraction and addition, respectively, if to calculate and get the degrees that matches with the format that I have on this screen. Um, so that's all that's going on here. It's actually not complicated at all. If it's greater than 0 and less than 270, I just add 90 because I think what they calculated is over here. So it makes sense that to go into here, I have to add 90 degrees to it. And then just add 450 if it's greater, if it's not inside that, to get it all the way around. And so then, yeah, this, the new point I make equal to, the ones that I calculated up here. And then if you notice up here, that's those new points are what I make X and Y equal to. So that's it. I mean, it's, I'll admit, like, this can be a little confusing, but honestly, I just looked it up. I found a formula on Wikipedia, and I was able to just convert it into JavaScript code and got it to work. And so then I just print it to the screen to just make sure it works. So to make sure that we're getting the correct angle that we want it. And that's it. Let me see, is there anything else I need to show you? So the set angle, that's right, that was called all the way up here in the INIT. And what that is doing, that gets called like at the start of the program. And it's the same deal as I was showing you up here, where I just need to kind of orient that angle to match the way I'm formatting it on the page, right? And so these, but basically what's happening here is every time that the page refreshes, I want to make sure that my starting point is halfway through the page, right? So canvas width divided by 2. And then this is the variable we use for the second point. And actually, I'm sorry. So this is our initial starting point for the variables right here. This will center that in the page, right? It actually overrides what I had done up here. So it overrides this 100 and 200 and resets those starting positions. Remember, these are static and never change. This one will change, but it starts out at the center of the page. Because this method only gets called once at the very beginning of the program. And it just makes sure that this is, and it also, well, I should say, it also gets called anytime we decide to change the angle. See right here, if we change the angle, this is your right arrow key and this is your left arrow key. The right arrow key will add 5 to the angle and the other one will subtract it. And so we want to reset everything. So this goes back to the center of the page. This is, make sure we clear that one. And then our ball is set to those initial values of the center of the page. Our radius is 20, the color is red. We're not using status at all. And that's it. And then the angle, which is displayed to the screen, again, this is just, like I said, reorients it to match the orientation that I have on the screen. I just threw a lot at you. Please, in the comments, let me know if you have any questions on this. Hopefully you found this fairly straightforward. My goal is that you can now, I'm going to share this code with you, and I hope that you can take it and edit it for your own purposes. Thanks. Let me know if you have any questions, and please subscribe.